In this presentation, we will talk about bioprinting technologies and the medical applications of 3D printing. We are going to first briefly talk about the history, then we'll move on and talk about the types of printers, followed by the materials used and their applications. This presentation will end with a look at what is to come in the future of biotechnology and printing. So here's the history. Biotechnology seems like a new technology, but is based on some very old discoveries, like cell theory and the discovery of stem cells. While these discoveries are very important, the first 3D printer was not created till 1984 by Charles Hull. Soon after, in the 1990s, computers were made even faster and were able to print more complex files, which is essential for bioprinting. The next step in the creation of bioprinting is the discovery that cells could be arranged and fused together into different structures. Thomas Boland was the first person to print in cells. He biohacked a normal inkjet printer to be able to use cells. He ended up printing his own initials. Between 1998 and 2003, when the first braille printer was created, many small scientific breakthroughs happened. For example, the first lab-grown organ was implanted in 1999, and in 2000, the medical field started using 3D printers for medicine. Moving along along with the creation of the first bioprinter in 2003, the mapping of the human genome was completed. Later in 2006, discoveries were made that mature adult cells could be reprogrammed into stem cells. Even later that year, the first lab-grown human bladder was implanted. In 2009, the first blood vessels were bioprinted, and since then, other organs like bones, ears, exoskeletons, blood vessels, windpipes, vascular networks, tissues, and even simple organs have been printed. There are three main types of printers: inkjet printers, laser-assisted printers, and extrusion-type bioprinters. The first one we will talk about is the inkjet printers. Inkjet printers work by first making ink, which is made of the patient's cells and chemicals to act as binders. This ink is then loaded into cartridges like the ones found in a normal home office printer. The file is then sent to the printer. Once the printer receives this information, it starts printing by releasing droplets out of the print head using pressure. Research is even being done currently to be able to print on wounds instead of just slides or petri dishes. The next type of printer we will talk about is a laser-assisted printer. This printer is very different from the previous one in how it works. The ink is a bio-ribbon, which is made of a top layer, normally made of metal, and a bottom organic layer containing the cells and medium. Once loaded into the printer, the files are sent to the printer. Then the laser is pointed at different spots on a scanning mirror, which then sends the beam downwards into the focusing lens. The beam then goes into the bio-ink ribbon, which vaporizes the first layer made out of metal and hits the organic layer, causing a droplet of that layer to be deposited onto a petri dish or slide. This process is repeated until the structure is complete. The final type of printer we're going to discuss will be the extrusion bioprinter. For this printer, multiple types of gels can be loaded into the printer at the same time, each containing different types of cells and mediums. The file is then sent to the printer. The extruder pipes out these gels in a specific place according to the file, and layers them on top of each other to make the structure that the file told them to make. Extrusion printers can also print other things than just gels. They can print in harder materials when they are trying to make things like implants or bones. Each of these printers has its own set of pros and cons. While the inkjet printer is good at printing small flat things like skins and tissues, it's not good at making large structures and the printer sometimes ends up killing the cells if the print head is too hot or too cold. Also, the pressure put onto the cells when the printer is printing can cause the membranes to explode, so it does have some faults. The laser-assisted printer has amazing accuracy when laying down the ink, but struggles to make 3D scaffolding, and scientists are still struggling to make exact microstructures with this printer that mimic tissues exactly. The extrusion printer, on the other hand, is amazing at printing large things like organs or bones, but can't really get the amazing accuracy that others have when printing small things. Overall, each printer is very different from the others, but every printer has a purpose and can be helpful in the medical field in different ways. I briefly talked about inks and gels when trying to explain how the printers worked. Here are a handful of other materials and chemicals that can be used to print different things. The chemicals at the top are best suited for printing things like bone scaffolding and hard things. The ones to the left are best for printing tissues in general. The ones in the bottom are powders that are mixed with other mediums for printing. They print specifically for inkjet printer tissues. And the ones on the right are for printing laser-assisted tissue specifically. These are only a handful of the materials that can be used, but there are hundreds of others that can also be used, and more are made and discovered every day. It may seem that the application of printers is only to print the tissues, but they actually print many different things. The printers can print organs like ears and arteries to be transplanted into a patient made from their own cells so they won't be rejected. They can also print tissues to replace missing or damaged tissues on a patient. Another use is to print bones, implants, and prosthetics. The technologies are not yet at a point to where you can print a whole new arm, but they could print bones, implants like hip implants, or even prosthetics to help improve a patient's way of life and mobility. And finally, scientists are interested in printing small sections of different types of tissues to test different drugs and see how the cells will react when the drugs are administered. This could help with the pharmaceutical development of these drugs. Here are some images of things that could be printed from these printers. On the top, there are things like organs or like ears and skins. And then on the left-hand bottom corner is actually a 3D printed artery, which I talked about earlier in the timeline, had been printed. Also, in the bottom row, there's a picture of an implant that was perfectly made designed to fit the skull. And a prosthetic, which is less expensive than a normal prosthetic, and is ideal for children because they're always growing and always changing. So a less expensive prosthetic would make it so you can have more of them and have one that fits a child perfectly every time that they grow. So the future of bioprinting is bright. There are many different applications and uses for bioprinting, and the list is endless. The number one thing that scientists are striving for is to make a fully printed organs out of the patient's own reprogrammed cells so that the organs will never be rejected when transplanted. They have done some start on this, but they want to make more complex organs, something maybe like a heart or like a liver with many different types of cells in it. Another future bioprinting has in the field of pharmaceuticals and testing drugs and their effects. This has already begun, but it's still in the starting phases, and scientists hope that one day they will be able to implement this application and allow this process of testing drugs to be more ethical and faster. So by printing the tissues for the testing, they were able to not have to use animals and things, and they could just test it on the cells themselves. This could make testing even faster and could make drug release even faster also. And the third thing that people are looking at. So finally, even the beauty industry has taken up research in the field because the technology could allow them to remove old wrinkly skin and replace it with new skin. Even though there is a bright future for bioprinting, there is still ethical concerns like who should have access to it? Should it only be the rich or the poor? Should everyone have access to it? Should people get charged for it? Where is the line between helping someone and remaking their entire bodies? Like, is that ethical? Should they do that or not? And if it should be allowed in cosmetics at all, should you be able to reprint your whole face or your whole skin and replace things like that? So those are just a few of the ethical issues that they're facing right now in bioprinting. And then these are my resources, and I'd like to thank you so much for listening to my presentation. And if you have any questions, please comment for me to answer them. Thank you for listening.